Dr. Hans Kandel is the NDSU Extension Agronomist based at the main Fargo campus. Hans has developed extension programs for producers in Northwest Minnesota and North Dakota that blend agronomy, crop, soil science, and economics. He also conducts applied research with various broadleaf crops, including soybean. So thank you so much for joining us, Hans.
Yeah, Carrie, thank you.
Fantastic.
I have been working on soybeans quite a number of years. So today I'm just going to give a few of the highlights, and especially for you, Carrie, you're newer, so I'm going to present it to you. So today's talk is basically on extension focused research, because in extension, we want to be practical and give, as Kandel was already saying, all the research that is conducted and bring it to the growers. So one of the research sites that we have at the campus, or at least near the campus, is what we call Northwest 22. That is the box in the center of the graph. That is a research site where a lot of the weeds people have their plots. But also I've been conducting some tile drainage research. So in the blue area on this graph is where the research plot is located. And it is a replicated plot with tile and non-tile. So if you look at this particular block, it is divided in 8 sections, and each of those sections has a control box to control the water level. And 4 of them we have completely closed to mimic non-drainage, and 4 we have put up so that we can manage the water table. So the water drains into a major ditch, but our plots are kind of into the research area, so it is not too close to the ditch, so that there's no influence of the ditch. So it was installed specifically for this research. So each individual block with 8 had a control structure, as you can see in the top right. I'm just going to show you a couple of pictures. The picture on the left, on the top, shows you where some of the tile is actually working and the water is removed. If you look far in the picture, you see some water standing. That one was the non-drained. And on the right, you will see that there is a drained area. So in the picture, it is a little small, but there are some control boxes there for those units. So what I'm going to talk about is some kind of a compilation of the data over the many years, comparing where we drained and where we didn't drain. So the non-drained, we do have tile in the ground, but because the box is closed, it acts as a non-drained area. So a couple of interesting things. We do usually some different trials on the tile and the non-tile. It can be varieties, it can be fertilizer or so. But what I wanted to show you here, that on the left are 4 varieties where the yields are expressed in bushels per acre on the left, where you'll see tile, and on the right 4 you see it is non-tile. Now, if you just look at the 2 groups, it is obvious that the tile group as a group is yielding more, but you can also see that some of the varieties respond different under tile versus non-tile. So for instance, the second bar on the right group has, I put there kind of an arrow, that is the difference from about 34 bushels in the non-tile, and it goes to the first bar on the left to about 37 plus bushels. So what we have also found is that there is kind of an interaction between, once you improve the conditions and you have good conditions for growth, you actually can pick varieties that can maximize those conditions. So there is a selection possible of varieties based on their higher performance. So I don't have enough time today to talk about all the trials, but I just wanted to give you an overview of some of the results. So in this graph, on the bottom, we see years from 2011 to 2019, and there are 2 bars for each year. The blue bar is indicating the no tile, and the red bar is indicating tile. And on the Y, you see it is expressed in bushels per acre. So this is each year, and these numbers is just not one number, it is replicated. So we have replications, and then within the replications, this is a combination of all the treatments. So if you look here at the bar, typically we see that the red bars have been out yielding the blue bar, so tile has worked. If you look at years 2016, 17, we see that the difference is very limited. So if it is a dry year, the tile, of course, does not run and the effects are not as dramatic. However, there is no negative effect in most of the years with tile compared to no tile. And then in the end, you see the last bar, the average, we see that there is a significant difference over those years. So if I just calculate it for the years that we are seeing now, we see that there is a 7% higher yielding across all those environments. And this includes looking at varieties that were not maybe the best adapted to tile or the best treatments, but on average, you can say 7% yield. Now I want to kind of show you that if you have tile, there is another benefit. With tile, typically we can plant earlier. So I'm comparing here the early planting varieties in the red bar and the late planting varieties in the green bar. So on the left, the two ones is on tile and the right two are non-tile. So I'm comparing here early planted tile versus non-tile. And if you look at that difference is 13 bushels, which is 28%. But if you would compare the green bar, which was late planted on tile and late planted on non-tile, the difference is not very big. So simply said that the benefits of tile are more pronounced if you use the best varieties that are adapted, the best management, but also early planting. So I know that tile works. I cannot just predict how much will it be on a yearly basis because the numbers will definitely be changing every year. So one of the other things that I'm looking at is the water table. So here on the left, you see a control box. We then measure the water table. Within the field, we have also some observation wells where we measure the water table. So the following graph is kind of an example. I've got many of these graphs, but just kind of an example. So on the top, you see the year 2013, going from June all the way to October. Then you see on the top, the zero, that's the surface. And you have to kind of look down in the surface is where the water table is. So we have here two lines. One is the red is the non-drained area, and the blue is the drained area. Now, I said I have control boxes. So the control boxes, how they work is in the upper part of the field where we see that there's the crop growing in this graph, we can set the baffles and raise the water table higher than the actually tile line. And if you have too much rain, the water can go over those baffles and can still go out. So in this particular setting, we have the tile set on the blue line on the bars for the tile. However, the tile line was 3 feet down. So you can see here, I'm holding back a little bit of water in the blue area. However, the non-drained was closer to the surface. And if you look at it, there is only 1.5 feet below the surface is where the water table was. Well, that's too close for our soybeans, and you will see typically a negative effect. The other thing to show here is that as the season continues, the soybeans are taking up water, and both of the water tables are dropping dramatically. So typically, our most important period for managing is that early season from planting up to somewhere the middle of July. And after that, the crop is also starting to utilize the moisture. The other thing, of course, is when we are working in the ground, you need to be able to get into a field. So here you see a couple of disasters when a piece of equipment goes in and there is no carrying capacity, it can go down. So we have been looking at penetrometer meter readings. And as you can see on the right, one of the students is kind of pushing the device into the soil that gives the resistance. So the more resistance there is, the more the carrying capacity of the ground is. So just here are two graphs. On the bottom is the depth. So as you push down the instrument, you get a reading for each depth. On the left, you see the resistance. So the higher the resistance, the more the carrying capacity. And I'm comparing here drained and undrained. And the drained is obviously a higher carrying capacity. So For drained, it is not only looking at the crop itself benefiting, but also the management. Farmers can get into their fields quite rapidly. So the other research that I've been involved with is looking at raised beds or ridges. And the idea here is if you cannot afford to put in tile, what about raised beds? And this research has been done in basically the eastern part of the country, of the state. And I'm just giving you a quick snapshot. Flat means no ridges. Raised beds is the small ridges. And I'm kind of focusing on the last column. We see that there is a significant increase in the raised beds. So this would be another method in managing the water, because the water will be shed in between the ridges and the crop can grow on top of the ridges and does not suffer from waterlogging. Now I'm going to talk a little bit about another major project, and this was conducted together with many of my colleagues in the region, and also Peter Schmitz was involved in this. And this we called a benchmark project. It was funded by the regional check of dollars, and it was done by many of my extension agronomists in the region. So we took over 8,000 samples of fields. In the north, you can see North Dakota. All those dots represent fields that we got data from. So the reason behind it is that if you are looking at the variety trials that are conducted, now I'm taking here 2016 because it was kind of a nice, very nice year with a high productivity. So in our trial booklet from NDSU, we had 65 bushels per acre yield, whereas the farmer yield reported from the statistical service in that year was 41 bushel. So there is a gap between what farmers are getting and what is potential. Now, when we say potential, that was potential in our trials. The genetic potential is even more, because even in our trials, we did not obtain the genetic potential. So there is even more potential there. But I'm concentrating on the difference between what farmers got and what the research plots are giving. And of course, you can see that there are management factors that involve how the crop actually performs in the field. So our objective for the benchmark project was, first of all, to understand what farmers were doing, and then based on that to conduct some research programs to verify some of those things that were identified by growers. So what we did, we sent out to growers a big questionnaire with a lot of information asking about variety, planting date, seeding rate, all the management aspects of 4 fields. And then we followed up with the grower to ask some additional questions. Now, we do realize that we have a variability in our environment in North Dakota. We have the Red River Valley, and we go to the west, we see that we have a different type of parent material, soil type is different, and water holding capacity is different. So if you look at this map, it is looking at soil productivity, the darker color, more productive than the lighter color. So what we did based on those regions, we kind of divided up the state in some regions for soybean production to see if we can differentiate between the various regions in the management recommendations. So these were fields surveyed in 2014 to 17, and all the dots represent the fields that we have data from. So this is just kind of a snapshot to show basically the region 1 to 9 corresponds with the yield. So if you go to the southern part of the state, this is the average yield of 206 farmers was reported 47 bushels. And you go all the way to the west and you go to the north, there were 55 growers that reported 36 bushels on average yield. So you can see there is a yield difference potential within the state. I will come back to this graph with some more information later in the presentation. So one of the questions we asked was about rotation. And one of the things that we know is that there is an effect of rotation, just soybeans on corn. But what we asked is, can you give us your soybean yield and your previous corn yields and see if there's a relationship. So here we see the previous crop corn yield on the bottom in bushels, and on the left, the Y, you see the soybean yield. And as you can see, there is a relationship between if you had previously more corn yield, you also had more soybean yield. So there is a couple of confounding factors here, but just kind of for you to understand that if you have better growing conditions or you are a better manager, those result in higher corn yields. And if you are in those conditions, it is also likely that your soybeans are higher. So there is an environment and a management aspect in this particular graph. So the next important point I want to discuss is the planting date. So on the X, you see the day of the year. So the 1st of May is the 121st day of the year. So I just plotted it out here. So basically going from April into June, and on the left, you can see how many fields were planted on that particular day. The total data set was over 1,100 fields. You see on the left, very early planted, and on the right, very late planted. So I eliminated those out of my data set. But on average, planting was taking place roughly in the middle of the May when most of the farmers were planting. Now, what I did is I got all the information from over 1,000 fields, and I just averaged for each planting date the yield. And then we put a regression analysis to it. And as you can see from the graph, there is a reduction in yield over the whole state when we planted later. So in this particular case, based on the formula, we could conclude that it is about 1/3 of a bushel delayed planting reduction. So every time you delay planting one day, you can expect 1/3 of a bushel less. I'm not saying you have to plant as early as possible, just regardless. No, we always say you have to plant early if you can. So the soil conditions have to be right, the forecast has to be right. Maybe tomorrow is right to plant, but it is too early in the season to start planting. We will have still frost coming up. So when I tell farmers this, I tell them, if you go fishing and you decide not to plant, the result is that you have 1/3 of a bushel less potential. So during your planting time, try to plant as early as possible. The second factor that we were looking at is here at the maturity group. So here on the bottom, the number 5 represents the 005 maturity. And if you go to the right of the graph, the 225 represent the 1.5 maturity. So this is the maturity as reported by the growers and the yields. So again, here you see over the whole state that there is an increase in yield potential about 0.7 bushel per 0.1 increase in maturity. So if you can plant a maturity that's a little bit longer, the likelihood is very strong that you will have a yield increase. Again, there are a few confounding factors in this, that in certain parts of the state, northern part, you cannot plant late maturing varieties. So the graph on the left is representing more the areas in the north, and on the right, more in the south. But this is kind of comparing all the data sets. Now, if you kind of plot out what farmers actually are using for maturity groups, this one is kind of graphing it out. And as you can see from the lines, they kind of bend a little bit down towards the west. Typically, when we think about maturity, we always think about a north-south graduation. So in many parts of the US, those lines are kind of east-west, and then the next line is a bit more north or south. So the reason why we see a curvature here is because in the West, we have a little bit more challenges with moisture in the second part of the growing season. So farmers, knowing that, have also selected earlier maturing varieties. So this is what farmers have reported as their variety selection for maturity. Now, this graph I showed you earlier about yield potential, but now I superimposed on it also the maturity. So although there is a difference in yield going from the south to the north based on just the soil, there's also the length of the day, the season, and also, as you can see here, the earlier maturing material. So some of the things are kind of intertwined. Now, the interesting thing that we have been asking is, what company seed are you using? So here we have 1,100 plus fields, and the farmer is saying what variety from which company is in each field. So on the left, it is in percent. So I want to draw your attention to, there are 3 bars on the left, that is Asgrow, Pioneer, and Cropland. And total, they have 48% of the fields that we surveyed that have those 3 companies. Now, unfortunately, those 3 companies do not enter their varieties in the NDSU variety trial booklet. So they are not tested in our NDSU system. So unfortunately, we're only testing about 50% of the varieties that are out there. I talked a little bit about the state and the maturity. In this case, I'm looking here at one company. So what we did, all the varieties of the 006, the 008, we averaged them out and we put them here as a yield. So here you can kind of see that there is indeed an increase in yield based on the maturity for the company. So with the company, you would assume that if they call something 07 and an 08, that they are different because you don't want to bring the same product on the market. Now we have here a combination of Asgrow and Pioneer. Now maybe if you can look at the first 3 bars for the 006, in that case, the Pioneer is a little higher, the 008, Pioneer is a little higher, the 03, Pioneer a little higher, then the 05, it is the other way around, Asgrow is a little bit higher. So this is data from only those 4 years. If you would plot this data again this year, the bars will be probably different. But what I wanted to show is that farmers, if they go just with one company and just have various maturities, now sometimes the company has the winner and another year the other company. So this is kind of a continuous change. And that is why we always recommend farmers to pay attention to the results from variety booklets so that they pick varieties that are truly high yielding. So just kind of a summary of this slide, the total yield from Asgrow and Pioneer was not significant. So if you look at the end, the companies are very close. The next question was about seed treatments. And there are a number of growers that did not use seed treatments. Out of the 1,100, was about 32% that did not use seed treatments. And I'm talking basically about fungicides. And the other ones did. And if you look here at the graph, you see that seed treatment significantly higher yielding than no seed treatments. And based on other research that I've conducted, there's an experimental plots that seem to hold true in our experimental areas as well. The next couple of slides, I wanted to show you that we actually went to the fields to do some observations, and we selected out of all the fields as many as we could visit in those 2 years. So we physically went to the fields, and then we did some observations, but one of the things we did was looking at the population. So we did do a stand count, and here are a couple of graphs that you see that, when a farmer plants, sometimes the seed doesn't germinate because the seed is on the top, or a plant germinates and it dies off. So the seeding rate and the plant establishment, there's always a difference. But what we also found here, that if you go counting from early season, this plant established, and go all the way just to the reproductive phase, we can see that there is a significant reduction in yield. So the first number is the counting the second half of the season. So if you graph that one out over the whole state, there is a little bit variability, and that might be just the numbers. But on average, you see that nearly everywhere you see in that range to 5 to 6% of plant reduction between the established stand and the stand at the reproductive phase. We did calculate the plants that were in the field, and then at the end of the season, we asked growers to give us their yield. So we graphed everything out, and we came to the conclusion based on the farmer conditions that if they had a final stand of about 140,500, then they maximized the yield. And in this particular set, it was in about 44 bushels for those farmers. Now, the next set of slides, I'm going to kind of talk about research that we did based on the findings of the big survey. So one of the measurements we were taking was called a Canopio. That is a covering app. You take a picture. On the left, you can see two pictures. In the center, this is wheat, but it gives you an idea, green pixels. And that translate everything that is green into white and everything not green into black. And then it gives you a ratio. So it is a very quick way to see how much cover there is. So what I said, this one is based on some of the trials that we were doing. This is over 15 environments. And this one was based on, let's look at the seeding rate and the yield potential. And also we did some measurements on early season and late season stand. But what I wanted to focus here on is that we measured also iron chlorosis. The score is from 1 to 5, where 5 is total plant loss, 1 is completely green. And over those seeding rates, you can see that if you increase the seeding rate, you decreased IDC. And this is just confirming what we already know from other research as well. The next one is that Canopio reading. So this one was kind of looking at the early mid-season part, just at the reproductive phase, going from lower seeding rate to high seeding rate. And we see there is more cover. And more cover has to do with more interception of sunlight, but also better competition against weeds. The next column is plant height. So as we increase the seeding rate from 80,000 to 200,000, we also increased the plant height because there was a little bit more competition between the plants. They were a little bit taller. But of course, what we are most interested in is the yield. And as you can see here, the yield increased. But if you look at the data with the A's and the B's, from 140,000 to 200,000, basically significantly the same. But low seeding rate, you will lose some yield potential. The other factor that is very important in North Dakota is the row spacing. And 24 inches is a little on the wide side. So all the research I've done so far, also with other RECs, says don't plant 30 inch or 24 inch, go narrower. And here it looks here at the yield. We see there that there is a significant increase if you narrow the rows. I want to point out that the final stand of these trials was the same between 12 and 24, but this one was now under research conditions. Also under our research conditions, we found that there is a difference between established stand and end of the season stand of that 5-6% range. So this was confirming that what we found in farmers' field actually is also true in our research plots. Let's talk about the next section of my talk today. Earlier, I was sharing with you about a large survey among growers. And out of that survey, we found that it was important to kind of start looking at combinations. We could tease out separate things, but what we wanted to do is to kind of look at the combinations. I've already showed you that early maturing tends to be low yielding than late maturing. planting date, very important. I showed you some data on row spacing, and also the population may be of influence. So this particular trial was looking at the combination, not just at single factors, but now seeing at the different interactions. So what I try to do is first give you a bit of an overview, a quick overview. In 2020, we did have an early planting date. So as soon as we could get into the field, and then we waited about 2 weeks and planted again. So each bar is, or each environment has 2 bars. The red bar is early planting, and the green bar is late planting. The yield is indicated in bushels per acre on the left, and then on the bottom is just each environment. And you can see that in most cases, early maturing or early planting will outyield late planting. So if we combine that over the 2 years, we see that the average was about 7% higher yielding by early planting. So some of those numbers seem to be coinciding with what we have found in the survey. The trends are the same, that early planting, yes, indeed, will give you a better yield potential, and this is under controlled conditions. However, we need to realize that some years we can get also frost early in the season. So last September, we had an early frost. So sometimes the things that we recommend may backfire. So early planting didn't backfire because everything was mature in time. But if you look at combining kind of a later maturing variety, now it is a little bit more tricky. So we have here a variety with an 05 maturity compared with an 08 maturity. And here I just wanted to point out that in Ransom County, the early variety yielded more than the late. That is not often that happens, but it happened because of the frost. So there is a chance that if you are pushing your maturity, that you run into some frost issues. So if we look at 2019, it was very clear that later maturing was higher yielding. In 2020, not due to the frost. Overall, still a later maturing has the benefit. And in this case, it was about a 6% increase in yield. So the last thing that we were interested in is looking at seeding rate. I already earlier kind of mentioned that with a higher seeding rate, we sometimes do not see a significant increase in yield. So in this case, average across all those environments, we did only see a 1% increase, so marginal. Now, the interesting point that I wanted to point out here is that this is the combination of early planting and late planting, and the red bars is the early planted, and then if you look at on below it, it says the variety. So the 08 is an 08 maturing, and on the right you see the 05 is an 05 maturity, and then you see on the bottom you see the seeding rate. So the highest numerical was early, late maturing, and high seeding rate, but it was not significantly different from the early and the lower seeding rate. However, if you just look over all the A's, that one is, everyone is early planting. So early planting is the dominant factor in looking at maximizing yield. But then when you go with early planting, you see also the 2 red bars on the left is the 08, and the 2 bars on the right is the 05. I could not pick up significant difference, but the trend is that we see the earlier maturing is definitely the definite driving force in the yield potential. So I'm going to quickly mention a couple of other things before I close. And it is one of the questions that farmers always have is, what if I use product A, B, or C on my soybeans? Will it give an increase? And one of the questions we oftentimes get is about a certain sprays with nutrients. So here we tested a number of products on the left. On the top bar, you can see the elements that were in those products, and then we used an untreated control. So basically what we did, we applied it just at the R2 stage according to the labels, and then we snipped off some leaves just before application and after application. And then we went and looked at the content of the leaves. So first of all, the blue bars is when we did pre-application, and then we did 2 weeks later. So as the plants were growing, also the nutrient content increased in the products, as you can see in the control on the right. I put a bar around the boron treatments. Those were significantly higher with boron content in the leaves than the other products, and comparing it to the control. But we can have a higher concentration of nutrients, but what counts is the yield. And here we are looking at yield for 2019 and 20 and the 2 years over all those products and the control, and you look at it, there is no significant difference in the treatments. Now, the interesting thing about this particular project is that I've been doing this trial with some of my colleagues over the United States, and all the dots here represent where the exact same trial was conducted. And you can see in North Dakota, that is our yield. This one is data from 2019. And then we also looked at 2020. And when we look at those yields in 2020, no difference between the treatments in all the environments, 24 environments. And then we look at 43 environments combining to 2019 and 20, no difference. So I'm very confident that if you just randomly apply one of the products without knowing that you need the product, you probably are going to waste your investment. I'm not saying that there is not a need for some of the micronutrients, but we need to tell farmers that if you don't know if you need them, if you apply, the chances that you get a return is limited. So I'm going to kind of end up here because I can talk another 3 hours, Carrie, but I think this is long enough for today. If there's any question, I will be happy to answer some of those questions.
Great. Thank you so much, Hans. I appreciate how many things you talked about. I know there are questions in the audience, but I also have questions, so I'm going to start with mine. So in the very beginning, you talk about your tiling experiment, which I think is very interesting. I'm assuming that, are you looking at tiling from the aspect of just tiling itself, or are you trying to mimic flooding conditions? Because I know flooding is a huge issue in North Dakota.
Yeah, so basically we have, it is replicated. So 8 blocks, 4 of them, we have just the natural rainfall. And in some of the years, you get these wet conditions, as I showed in the picture. Comparing those with managed drainage. So I have set the tile line so that I'm managing the outflow of water. And then within those blocks, because those blocks is about 0.7 of an acre each, I have these other experiments to see, is there an additional benefit of using tile, comparing it with no tile. And there we see that variety selection is critical. Utilization of fertilizer is more efficient on tile. Planting can be done earlier. The carrying capacity is better. So I'm gaining a lot of additional data sets because it is a replicated environment.
Yeah, I haven't seen anyone construct such a controlled tiled environment before, so it's really interesting to me. How big is that entire experimental area?
So each unit is about 0.8 acre, and we have 8 blocks.
Oh, okay. And then, since you're the extension agronomist, I have to ask too, do you have any idea how much the economic damage due to flooding is in North Dakota?
Well, it's an interesting question, and there are a couple of different ways to look at it. So Dr. Helms in the past did an experiment where he on purpose over irrigated with sprinkler irrigation the soybeans at the bloom stage. So he kept them wet during that critical stage, and it was somewhere 17% yield difference. Now, flooding and stress occurs at various stages in the season. So sometimes it occurs early in the season, and sometimes it occurs late in the season. So it is hard to know exactly, what the number is, but just very conservatively looking over time, a 10% yield reduction would be in the ballpark. So if you go from 45 bushels, you have 10 bushels yield loss, which is 4.5 bushels, and let's say $10, that's $45 yield loss per acre. And then we don't have it on the whole area, but some years we have many, many acres that can't be planted. So you could say then it is total loss. So the economic impact of having saturated conditions and yield reduction are enormous.
Thank you. Yes, I've even just in our experimental trials, we've even had a hard time submitting data to uniform trials because we've lost entire locations due to I don't know if you would call it. I know that there's specific terms for it. I don't know if you'd call it flooding if there's not standing water in the field, but the water, short of the long, the water table is so high that you have significant root damage. So, okay, so let's get to some of the other questions. I can't hog all your time. I can talk to you whenever I want to. So one question that has come up several times, you talk about your early versus late planting. Can you give more specific dates for what is early versus late?
Yeah, so I was trying to mention that we need to use common sense, right? So in North Dakota, if you just look at the statistics, most of the farmers will plant, in that 15 to 20 May if they can. So that's kind of statistically where people are talking. So if you can move within a few days, and instead of the 15th of May you can plant on the 10th of May, you're gaining that yield potential, and even those few days make a difference. So therefore, if you look at early planting, I'm always looking at the opportunity. So if your field conditions are ready, and we have warming soils, we don't have a cold front coming that will dump cold water, and the forecast is good, and we are somewhere in May, then I would say early planting is plant then. But I'm not advocating planting on a calendar day, because that would be disastrous.
Yeah, I know I'm new to this state, but certainly knowing when is winter actually over and when is it actually starting, especially when we had that early frost last year, the second week of September. Now I'm just pretty much terrified of growing soybean, but it's okay. We will triumph through. Barney Geddes, who is a new faculty member here at NDSU, asks, do we know why increased seeding rate is correlated with reduced IDC?
Yes, that's a good question. Later we will get Jay Goose on the program, but it has to do with the exudates of the root. So the roots acidify around the roots, and then the iron can be taken up. So if you have more plants, then the root zone has a little bit more acidity, and then they can benefit jointly. So that is kind of the short explanation why that would be increasing the number of plants closer together would give you better results. So if you go from narrow to wide rows, then the spacing within the row increases or decreases, and you get less IDC with wider rows, but you give up a lot of yield. So there are tricks to manage the IDC a little bit with seeding rate, but we have to go to carry and get the best IDC. That is the number one treatment.
That's right. IDC. That's right. That's all you have to. You don't have to worry about anything. The soybean genetics will take care of everything. And it's not on a last note. It's not really a question so much as it is a very strong statement. Berlin Nelson says, Hans, don't forget the role of flooding with root rot.
Well, Berlin, you know for sure that I've not forgotten about that, and I don't talk about it today, but it is very obvious that the response in the tile, we see less Phytophthora and other things. That's kind of an obvious. You can talk about it later, but that is one of the benefits of having controlled drainage. We have aeration in the ground. We don't have that wet condition, and there is definitely less chance for root diseases. So thanks, Berlin, for bringing that up.
Great. Thank you so much. It was a really fantastic talk. We really appreciate you being here, Hans. As the extension agronomist, you are the person to go to know what's actually happening in the state.